welcome. In this lecture, we're going to go through a little bit of help in kind of identifying when to use integration by parts and also what the parts might look like. So often we're going to have, so what do these functions look like? So f of x is going to be a function that's kind of simplified by taking the derivative. So f of x is a function that's actually simplified by taking the derivative, because you're going to want to integrate it after taking the derivative, and so it's going to help to like simplify it so it's an integral you can actually do. Okay, so simplified by taking the derivative. For example, with our functions that are simplified by taking the derivative, this is a little bit funny what I've got going on there, derivative. For example, polynomials, right, because the degree goes down when you take the derivative. If it's a high degree polynomial, you'd actually have to use integration by parts a number of times, so that would be tricky. Okay, and then g prime of x is a function that doesn't become any more complicated, becoming no more complicated when you take the antiderivative. No more complicated when you take the antiderivative. So if we think about it, what are some examples of that? Well, sine and cosine pretty much basically stay the same, and e to the x stays the same. So, you know, like cosine and sine, they kind of swap with maybe some sine in front. So cosine of x, or sine of x, or e to the x. There are other like tricky circumstances for using integration by parts, but this is kind of like the most standard. Okay, so here are some kinds of practice examples. So some practice examples. Okay, so here's the first one, which is that I'm going to take the integral of, and I'm going to take the integral of x squared plus 1 times e to the 3x dx. Okay, and if you look at this, you do actually identify there's a polynomial in there. So this is going to be my u. And then the thing that doesn't become any more complicated becomes my dv. Right? And so, oops, it's meant to be orange, not red. Okay, so that's my dv. So let's just kind of really quickly look at what actually happens with those, just for a little bit of practice, which is that I have u equals x squared plus 1. And then remember, we take du. And so this is going to equal. And remember how we do this, which is that we want the derivative of this and then dx next to it. Okay? And then dv is going to equal this thing here. So it's going to equal e to the 3x dx. And I slightly lied when I said that it was like e to the x. But this is close enough. This doesn't really become any more complicated when I take the antiderivative. All that happens is that I need a 1/3 in front. Right, why do I need a 1/3 in front? Because I'm going to have to apply the chain rule when I take the derivative to the 3x. So I'm going to end up with the 3, and I need that to cancel. Okay? Now, if you actually kind of work through this, in case you actually do that, I want to make a little remark here that you'd actually need to use integration by parts twice. Okay? So note, in this one, you'd need to use, you actually need to do integration by parts twice. Like the integral that you end up with inside the formula needs to be integrated again, using integration by parts. So you need to use integration by parts twice. Okay? Which is not actually that difficult to do. You just need to be very careful in how you do it with parentheses and so on. Okay? So let's look at another example. So in this one, I'm going to take the integral of 2x sine of and then I'm going to take x over pi dx. Okay, and if you look here, so we do have a polynomial. So this is going to be my u. And then over here, again, this is one of these functions where it's kind of like one of these. There's just a constant that we have to worry about, which is not a problem. We can do that. So this is going to be my dv. And then my u, so my u, remember I'll write u equals 2x. And then we'll do a little practice like we did over there, that I want to take the derivative with respect to x. So remember I'm looking for my du, so I take the derivative with respect to x, which here is 2. And then I get dx. Okay, and then over here I have dv, right? And now this is going to equal sine of x over pi dx, right? And that's like having a 1 over pi in there. So if you took the derivative, you would have to use a chain rule. So now you need to actually kind of be a little careful, and you're going to need to put a pi in front to cancel. You're also going to need a negative in front of your cosine, right? Because when we take the derivative of cosine, it picks up a negative. And we need the negative to cancel. Okay, so this is just, you may take a calculus class where they do very complicated examples of integration by parts. We have chosen not to do this just because it's the point for you in integration is more to kind of understand how integration works, and I really wanted only to introduce integration by parts in order to indicate that you do have to undo the chain rule so that you could kind of understand that. Sorry, you had the product rule so that you could understand that. And the reason we'll do substitution will be to show you, to have in your mind that you would actually have to undo the chain rule. Okay, so if it made some sense. And I'll see you in the next lecture.